And now it's a very special pleasure to welcome two young and talented colleagues of mine of La Mobilière. Simone Rösler, she holds a master in quantitative finance and economics, and she works as a data scientist in our customer analytics group at La Mobilière, where she's collaborating with lots of stakeholders to make our clients' life better. Then also, Yves Beutler, he holds a degree in computer science and has many years of experience in software development. He also works as a data scientist at La Mobilière in the same group, Customer Analytics. Welcome, Yves and Simone. They will tell you about how we handle customer feedback at Mobilière and gain valuable insights out of it. Thriving through customers, how to automate feedback processes with large language models. Come up, the stage is yours.
Merci. Dankeschön. Thank you very much, Matthias. Welcome, everyone, and welcome to our talk. We look forward to introducing you to our automated feedback process over the next 20 minutes. We all need feedback. Every person, every team, every organization. That's the only way we can improve. It's as simple as that. In order to obtain meaningful feedback and learn from it, we need effective customer feedback mechanisms. At La Mobilière, we send out approximately 150,000 customer surveys annually in order to evaluate our customers' satisfaction and identify potential areas for improvements in our products and processes. The surveys include a free text field where customers can elaborate on specific aspects of their experience with us. And about a third of all our clients make use of this opportunity. The purpose of this talk is to present our approach to efficiently gaining insights from this written feedback and to quickly identify where a quick or where response is needed. The difficulty of automation lies in the fact that the feedback texts can be very diverse, come in various forms and concern a broad range of topics. Some are typical feedbacks, where our clients praise or criticize us, and others include elements to which we need to respond promptly. It is therefore important to understand what things a feedback can potentially comprise, and how we need to respond to the different types of information. To this end, it makes sense to look at this exemplary feedback. We feel that the customer representative did not provide us with adequate advice. Could we please receive an overview of the different product customization options? The first and most obvious component concerns the content of the feedback. In the example shown, we see that the text is about the consultation process as well as the performance of our employees. The second component of the feedback concerns the existence of a request. This could be something to which we need to respond in a timely manner, like answering an inquiry or sending a requested document, or it could be something concerning like a wish for the future with potential ideas for our products or services. That would be something we don't want to miss, but where there's no immediate need to contact the client. And finally, the third component concerns the underlying sentiment. We aim to identify negative feedbacks so that we can reach out to our clients if needed. To ensure an effective and efficient feedback process, we decided to create one model for all of those three components. That means one model to detect the content, one model to detect potential requests, and one model to identify negative sentiment. The reason for this separation is that we wanted to reduce complexity, to minimize labeling outlay, and to focus on feedback where there is a request with need for action or an underlying negative sentiment, as it is this kind of feedback that requires a prompt response and for which we want to send out automatic tasks to our insurance advisors. Let's now have a closer look at the three models. The topics model is a multi-label classification that enables us to identify the content of the feedback, the topic of what it's about. This can include products, such as a car or a travel insurance, or different topics like payments, offers, claims, and so on. Each feedback can pertain multiple, all, or none of these topics. The topic model then eventually helps us to analyze the feedback and to detect trends and relationship within the big picture. The requests model predicts the existence of a request. Here we have a single label classification with mutually exclusive classes where every feedback can either include a request to which we need to respond in a timely manner. It can include a request with no need for action, or it can include no request at all. And finally, the sentiment model predicts the sentiment of the feedback. It is a binary classification where we aim to identify negative feedback as soon as it includes any negative aspect. But how did we get there? Before starting with the implementation, we aligned with our business stakeholders on what exactly they wanted to achieve. We discussed the definitions of the different topics and classes, and especially for the topics model, we tried to reduce the number of categories to as few as possible, so that only the most relevant classes would remain and the labeling outlay could be mitigated. Similarly, we used ChatGPT in order to predict the categories in advance and thus generate a sample for the business to label with as many texts per category as possible in the minimum number of feedback texts. Then we gave the texts to the business for labeling or to customer insights, and once we received the labels back, we ran different models on them. We started with rather simple zero-shot baseline models, such as DistillBERT, a condensed version of BERT, and then gradually tested larger, more performant models. We always compared the performance in MLflow, and for the requests model, we quickly realized that we had an issue. We didn't have enough observations of the class requests with no need for action. We therefore decided to use an alternative approach and tested ChatGPT, where instead of working with the labeled observations, we wrote a prompt and explained or gave the definition of the class or of the three classes, and including examples. And that worked much, much better, fortunately. However, we were not able to implement ChatGPT productively, or not yet at least, and decided to at least use it for minority relabeling. That means that we used ChatGPT in order to predict the texts that were most likely to belong to that category and gave those texts to the business for additional labeling. This really helped a lot and improved the model significantly, and we were able to keep the class as desired. Next, we tested if a pre-training of the mDeBERTa model with the unlabeled feedback texts to the language of Mobilière would further increase the model performance. However, we found that language adaptation did not really help and therefore decided against it. Finally, we tuned the hyperparameters of the best models, namely mDeBERTa for the sentiment and requests model, and XLM-RoBERTa for the topics model, and packaged the final models into a library. And with that, I'd like to hand over to my colleague Yves to provide you with more technical details.
Thank you, Simon. So let's move on and talk about model performance. But first of all, I want to give you a brief overview about the development setup we have at Mobilière. We are either working on Azure Machine Learning or on Azure Databricks. On both of these two platforms, we can choose from a wide range of different sized compute clusters, some of them with or without GPU support. All the models are provided by Hugging Face and are publicly available. During the development phase, we used Optuna for hyperparameter tuning, and all model metrics are automatically logged to Azure by MLflow. As Simon mentioned earlier, we began with some simple baseline solutions. Therefore, we picked the most suitable models from the Hugging Face hub, and we experimented with some zero-shot approaches. And yes, we achieved some decent first results, I think, as you can see on the table on the top right, but we also came across some heavy limitations. Let me explain that further. We took the pre-trained DistilBERT model. It was pre-trained on a sentiment analysis task, and we found out that it had some serious misunderstandings with the claim keyword. Unlike the English claim, in German the word Schaden is a bit ambiguous, and it can also mean damage, which is mostly negatively connotated. And our sentiment model was very likely to wrongly classify sentence or customer feedbacks with this specific keyword in it. Nevertheless, we got decent first results in just no time, and I would absolutely recommend trying out zero-shot approaches if you can find a suitable model for your own task. As we weren't pleased yet with the first results, we headed for more sophisticated model approaches, including domain adaptation and transfer learning as well. When we tweaked the hyperparameters of one of our most promising models, the mDeBERTa from Microsoft in version 3, we found out that we got the best results with a batch size of 32. Unfortunately, we didn't have that much memory on our GPU compute. Therefore, we had to switch back to CPU. So it shows that sometimes, even with the fastest hardware, it's not always the solution we are looking for. Needless to say that our training time multiplied. Another important aspect was how we dealt with the conflicting priorities of our stakeholders, because they didn't want us to spam the insurance advisors with a lot of wrongly classified feedback texts, which is totally understandable, but they also didn't want us to miss out on some important feedbacks. So we had several exchanges with them until we found a more or less optimal solution for this issue. Here we can see the business process in more detail. The data can occur in two possible ways, either by a Kafka stream or persisted as a data product in Azure Databricks in the Unity catalog. In the ingestion step, we fetch a batch of customer feedbacks from our Salesforce platform via Kafka, and then we parallelize the whole model inferencing part. After we got the results, the predictions, we need to apply some specific business rules to the outputs of the request and the sentiment models. This is to ensure that we don't send negative sentiments, for example, concerning third-party providers like a garage or a locksmith to our insurance advisors. They can't deal with this feedback. But no information will get lost because we save all the customer feedbacks and the predictions into a known data product into the catalog. The filtered feedback, on the other hand, is then published as a Kafka topic and is consumed by the B2E application. There it will be, a customer feedback case will be created. It will be matched automatically to the corresponding general agency, and at the end of this process, our colleagues out in the front, they will handle the open customer requests or get in touch with the customers directly. Another important part of this setup is the analytics dashboard we are planning to build with Power BI in the next PIs. The dashboard allows customer analytics, customer insights, this is our stakeholder, to look out for trends and relationships inside or between the different topics. If customer insights recognizes, for example, that a specific topic is associated with an increase of negative sentiments, a number of negative sentiments, then they will be right there to address this issue. The ability to detect trends is one major benefit of our solution. The outputs of the free models in combination will give us just the insights that we need. A single sentiment alone isn't that helpful without its origin. With the automatically created customer feedback case, we can react promptly to our customers' needs, and with respect to the limited time of our insurance advisors, we only forward the customer feedback with a need for direct action. Only the feedbacks that matter the most. Another benefit of this solution is that we establish another data-driven process inside Mobilière. This helps us to make us even more data addicted and understand the customer better in the future. Let me highlight some of the key learnings we had during the development. Labeling is not as simple as it first seems. It should be done by domain experts, but this can be a limiting factor, like it was in our case as well. We learned that especially for the topics model, a very large number of observations per category is key to let our model generalize its predictions and to succeed. Don't hesitate to use intelligent agents like ChatGPT. If you can't use them in production, you might still benefit from them during your development, as we did. ChatGPT was able to select a wide range of our customer feedbacks before the labeling process because our stakeholders, the business, created very sound definitions of all the categories, which we then used directly for the prompt engineering part. And a last takeaway we want to share with you is just to keep it simple. I'm sure you've heard this phrase 1,000 times before. That's because it's true. We had some tough meetings with the business, trying to reduce the number of categories the topics model has to detect, because with each additional category, the overall complexity and the labeling outlay would increase. Also, make use of pre-trained model for well-known tasks, such as the sentiment analysis tasks. You can start very quickly with zero-shot approaches and get the first results in less than a day. This will really impress your stakeholders. Thank you very much for your attention. Just for today, we will be happy to address your feedback personally and not through a large language model.
Wonderful. Thank you very much for this deep insight into a relevant use case we have at Mobilière, combining the best of two worlds, large language models and conventional language models. Questions? Right there in the back.
Hello. First of all, thank you for your presentation. I listened quite attentively because I worked on sentiment myself, and I also have a marketing consumer behavior background. So I wondered, why did you choose to have two categories, negative and positive/neutral? Because maybe a customer is really happy with your services, and that's a nice thing to know as well, and then to say, hey, thank you, dear customer A, that we've been able to help you so well. Here, you got, I don't know, a piece of chocolate or a little thank you card. That really makes a difference as well in the customer experience. And I just wondered, what the rationale was to only reduce the data that you've got to two categories.
Okay, that's a very good question. Thanks. Yeah, we also talked with the business about this specific case, and the reason was we wanted to automate the process. And for this case, only the negative feedback was relevant, but we also trained some of the models with feedbacks, which was in 3 different categories, with negative, with neutral ones, and also with positive ones, so that the models will have some more challenge, a large challenge while training, but that's a good point. So maybe we will think about that in the future and also make the best out of the positive feedback as well.
Another question right here in front.
What I haven't understood is, since the feedback comes out of Salesforce, it seems to be labeled with the respective client. Do you also correlate feedback, saying, oh, the garage XYZ is doing really bad, or the product in the region doesn't perform, other things to augment the whole analysis?
Okay.
Yes. Yeah, exactly. I mean, that's the point that's going to come very soon in our dashboard. So we are planning on creating a dashboard in Power BI where we want to combine the 3 models in the analysis. So there we really see the relationship between, on one side, between the topics and also their connection with the sentiment. So example, we see if a certain topic, like a garage, so we saw the third party, always appears of negative sentiment, that we don't miss that and can have a closer look at why this could be the case. Exactly.
I was just wondering, the feedback that you got from your clients, did you ask for the feedback, or they just tell you on the website or by some form, or? So where did the process start to get the feedback?
We have different processes, and maybe at the end of an adjustment to your contract, then we will ask actively to the customer, hey, would you like to give us some feedback? This is one of the possible ways. At the moment, we don't collect general feedback from the website into this application, but it would be possible as well.
Any other questions? Over there.
Thank you. Yeah, for me also your talk was very interesting because I've been also working with sentiment, and I'm wondering if you said you used an expert labeling, if it was always clear for the expert if the feedback was positive or negative, because in my experience sometimes it's tricky to tell.
Yeah, no, absolutely. I think it's something that we underestimated a bit. I mean, I think for us it was clear that for the topics model and also for the requests, it was sometimes very much a gray zone, basically on if the topics applied or not, if it was a request, if there was an action or not. The sentiment seemed to be the most straightforward case, but even there, sometimes it was difficult to really tell. But I think in our case, as we really decided to look at it in a binary way, so only is it negative, yes or no, that helped a lot, because we decided together with the business that as soon as there is anything negative in the feedback, we want to label it as negative. And that made it much, much easier to differentiate. And also because we're in the lucky position that our feedbacks typically are quite positive. So that's why we said, even if it's only a minor thing and the feedback overall tends to be positive, we want to label it negative if there is some kind of issue.
Thank you for your talk. I have also a question about expert labeling and using this labeling to classify the topics into different categories. From your experience, how much data do we need to label to support your language model's performance, or at least to give us some good basis? Thank you.
Okay, thanks for the question. I think it really depends on your case. So we had a bunch of topics which the model was able to detect with just a few hundreds of labels, but other more tricky ones, we needed 1,000 labels and more. So I think it really depends on your case and on your data. Yeah, but we made very good results with ChatGPT, for example, if you have a very sound definition of your label. So it's definitely giving it worth a try in the future.
There was one more question right there.
Thank you very much. You mentioned that you used ChatGPT and that its performance was very good compared to models that you've trained yourself, but you weren't able to use it in production. So I was wondering, have you considered using Azure's OpenAI service running on your Azure to perform this task?
Yeah, we consider, but this is an overall IT discussion, and it's not. We weren't able to use it yet. I think maybe in the near future, but when we started with this project, this was some months ago, then we hadn't had the possibility to use it. But yeah, I think we will definitely have a look at the future development of these models and how we can use them easily, and maybe also try an API, which would be maybe a bit more handsome way.
Thank you.
Great, so wonderful. Thank you very much, Yves and Simone.